G'day, Tim Neal, Data Farming. Just a quick summary on a variable rate nitrogen application we did this year. And thanks to Broden Holland, by the way, for helping the grower with his new protein monitor. This is from 2022 wheat crop, where we could see the satellite imagery on the left. You can see quite poor areas in the southern part of the field where a lot of water flowed over that field during this. We've had 2 or 3 years of wet season. And the yield map there, you can see that they correlate extremely well. No surprise, we see it all the time. Good correlations between yield and the satellite imagery mid-season. And then the protein map. This is his first protein map from the protein monitor. You can see again good correlations from those results. Now, what we did with Broden's help was actually create a variable rate urea map based on the protein only. So we don't use the yield for nitrogen prescriptions, just protein. And we apply a factor, which we did here. Just letting you know that the yields sort of varied by a few tons to the hectare there, so quite a big variation in yield. The protein varied the most, between 6 and 12%. So the red areas here are 6%, blue areas are 12%. What we did was also run a very big strip trial right through the middle. The grower wanted about 160 kilograms of urea applied. In this case, there was a bit already pre-applied. And so the 160 kilograms of urea was the same average rate as all the zones. So the red areas were receiving 50 kilograms of urea up to 300 kilograms in blue, and the average was 160, which is the strip we ran through the middle. So it was a good way to test this, and I strongly encourage everyone to run test strips. This is quite an extreme test strip. Normally it wouldn't do as much as this, but it does show in the next images what actually happened. So now we jump across to the 2023 season. This is quite late, 27th of August, 2023. And you can see this is using NDRE, a red edge index, not NDVI, but they looked pretty much the same. A couple of interesting factors here. One is you can definitely see the response to the higher nitrogen rates. This is the variable rate map on the right. Interestingly, you can also see in the satellite image the historical pasture areas that were ripped out probably 20 years ago or more. They're still showing up. So lots of residual nitrogen sitting under those fields. So it's really important to understand how our cropping systems have degraded those pools of N over the years. But definitely a huge response here to that additional nitrogen. And the comment from the grower was that the field evened up considerably where we did apply those higher rates of nitrogen. So that was an interesting find. Also, if you have a subscription, you can also look at the thermal imaging. This gave us a lot of confidence in the season because the crop was still obviously pumping a lot of water, which is good to know, because those high nitrogen rates we were certainly concerned about, haying off, so running out of water and haying off. But because this was flooded, obviously the low protein was caused by excess water and denitrification. So in this case, it was still pumping water, which gave us a lot of confidence. We're still getting the yield data in, he's still harvesting, but there was definitely a yield jump there, probably half a ton or more yield improvement. We're going to do the cost benefit analysis of this, but I thought I'd just give you a quick overview. The protein on the right needs to be calibrated, but evened up the protein a lot more as a result. So we'll get these results done for you and share them, but just thought we'd give you an early indication. So yeah, give us a bell if you need any help with this. Support@datafarming.com.au. Thanks for watching.